Hello student, today we are in the second lecture of the second chapter Polynomials. So in last videos I have discussed the basic concept of polynomials, like different types of polynomials and the degrees of polynomials. So on the basis of all this concept, today we are going to discuss some questions regarding that concept. So here the first question is, which of the following expression are polynomials? So here you are given 6 polynomials, so you have to check which of them are polynomials and which are not. In case of polynomials, write its degree. If it is a polynomials, then you have to write its degree also. Actually there are two questions. You have to choose the polynomials and write its degree. Now let's come to first question here. So we are given x to the power 4 minus 2x to the power 3 plus x plus root 3. Now how will you check a given expression is a polynomials or not? You just simply look the power of variables. So here variable is x. So what is the power of x? Here 5, here 3, here 1. So if the power of variables are positive integers or 0, they are regarded as a polynomials. So 5, 3, 1. So these are the positive integer, and that's why this first given expression is a polynomial. So I can write here answer. Yes, it is polynomials. Why? Because the power of variable is positive integer. Then let me write this degree also. So in short form, you write degree. So degree is the highest power of variable. So here we have power 1, here 3, here 5. So out of these 3 powers, which is the highest here? 5. So degree of the first polynomials is 5. Okay, let's come to second question here. Now again, you have to check whether this is polynomials or not. Now here x to the power 100 minus 1. So here x is a variable. So just look at the power here 100. 100 means again is a positive integer. Positive integer means 1, 2, 3, 4, 5, 6. So positive integer means yes, this is also polynomials. Yes, it is polynomials. And about the degree, so highest power. So since we are only x, one x term here, so highest power of x is 100. So degree of the second polynomials is 100. Now let's come to third question here. Instead of x, we have a t as a variable. So I have told you a variable can be x, y, t, so z. It can be given in any form. So you just here in first two questions we are given variable as a x, but here in third one we are given variable as a t. So it doesn't make any difference. So t to the power 2, t to the power 1. So 2 and 1. Again these are integers, positive integers. So yes, it is also polynomials. Yes, it is polynomials. And about the degree, just look the highest power here. So here 1, here 2. So highest power is t, 2. That is why degree is 2. Now let's come to fourth one. X to the power minus 2. Now here is a problem. Negative 2. So if the power of variable is negative number, then that expression is not regarded as a polynomials. That means answer is clear here. It is not polynomials. It is not polynomial. So if it is not polynomials, then we will not discuss about its degree. Now let's come to fifth question here. So now again they have changed the variable. Instead of x they have given the y. So here if you see this question, then y cube multiply with 1 minus y to the power 4. So that means you can simplify this expression further. Simplify means you just multiply it. Y cube multiply with 1 is y cube, and y cube multiply with y to the power 4 is y to the power 7. Now it looks simple. Now here power of y is 3. and here power of y is 7, and 3 and 7 both are positive integer, so it is a polynomial. It is a polynomial. And degree among 3 and 7, which is the highest? 7. So 7 is the degree of this polynomial. And let's come to last question here. Now x to the power 4. Yes, it is positive integer. X to the power 3 by 2. Now it is a fraction. So if the power of variable is fraction, then again this polynomial is not regarded. Sorry, this expression is not regarded as a polynomials. So definitely this is not polynomials. This is not polynomials. Why? The power of variable is fraction. So from these questions, I think you have again it helps to clear you the concept of degree and polynomials, all these things. So I am repeating you how to qualify an expression as a polynomial. So simply the power of variables would be either 0 or positive integer. In that case only that expression become polynomials. If the power of variable is negative number or a fraction, then it is not regarded as a polynomials, like in this one 4 and 7. So these two are not polynomials. Okay, let's come to second type of questions. So here write number 1 the coefficient of x cube in this polynomial. So actually this is our given polynomials. You have to write the coefficient of x cube. So coefficient of x cube means a constant number which is before the term x cube. So if you see this polynomial, so this is x term. So you have to look for x cube term. X term. This is x square term. Now this is x cube term. So this is, we are looking for x cube term. So which number is before x cube? So minus 5. So this minus 5 is called coefficient of x cube. So your answer will be, the coefficient of x cube is minus 5. Second question, the coefficient of x. Now here you have to write the coefficient of x in this polynomial. So just look for the x term. So this is x square term, we don't need it. This is constant term, we don't need it. So x term is here. So which number is before x here? Minus 2 root 2. So this number is the coefficient of x in this polynomial. So the answer is minus 2 root 2. Now third one, the coefficient of x square in this polynomial. So here if you see, we have x term, constant term and x cube term. So x square term is missing here. So if some terms are missing, then you can take coefficient of that terms will be 0. Is 0. So here answer will be 0. So why 0? I am telling you, this is x cube term, this is x term, this is a number. In fact, there is no x square term. If there is no x square term, then you just directly write the coefficient of x square term will be 0. Now fourth one, the constant term in the polynomials. So here you have to look for the constant term. Constant term means those terms which do not contain x. So this term has x square, x is there. This term also has x, but see the last term here, there is no x. So this term is called constant term. So constant term here is minus 2 by 5 pi. So this is how you look for the coefficients of different terms in a polynomials. Let's come to third type of question. So here we rewrite. So you have to rewrite this polynomials in standard form. In standard form. So what do you understand by standard form? So standard form of polynomial is you have to write each term in decreasing order of the power of variables. So that means we'll write highest power term first, then second highest power term next, and in that way. So here there are how many terms? 1, 2, 3, 4 terms. So which is the highest power terms? This is highest power term. So write 5x cube first, then x square minus 2x square, then x term, then a constant number. So this is your answer. So that means decreasing order of the power variable here, right? 3, 2, here 1, here actually 0, constant term 0. Now let's come to second question here. So which is the highest power term? This 2y cube, we'll write it first, and second highest is plus 4y square, and third one is minus 3y, and last you'll get 2 by 3. So a constant number, the constant term is always comes at the end. Now let's come to third one here. So highest power term, this, no, not this one, cube, here t power 4 is there. So this is the t power 4, and second highest is minus 3 t power 3, and square term minus t square, then plus t, and 2 plus 2. So this is your the standard form of given polynomials. So remember guys, the standard form means you have to write the polynomials in such order that the power of variables would be decreasing in order. 3 to 1, like this, 3 to 1, 0. Here also 4, 3 to 1, 0 are constant number. So thank you.